Hi, it's Chris, and we are taking a look at questions 8 and 9 here in section 4 of SAT Practice Test 4. So for question 8, it says that line L in the XY plane contains points from each of the quadrants 2, 3, and 4, but no points from quadrant 1. Which of the following must be true? And we see that all of our answer choices here are talking about the slope. The slope undefined, 0, positive, or negative. So first let's talk about what types of lines those would indicate with each slope. So here, if something is going to be undefined in terms of the slope, that means that it's going to be a vertical line. If something has a slope of 0, it's going to be a horizontal line. If something has a positive slope, it will go up and to the right, negative slope down and to the right. So we should know all 4 of those general trends when you have a certain type of slope in terms of the direction of the line. And so here, let's see if we can look at a coordinate plane and label our quadrants. So this first quadrant is right here where both your x and y values are positive, and then it counts up going counterclockwise around your graph. So this would be quadrant 2, quadrant 3, and quadrant 4. And that's just a must know for test day. So if that's something new that we maybe haven't seen in a while or haven't seen, at all before, then we just want to make a quick flashcard or add it to a Quizlet and memorize that, because that's key information. So let's take a look and see if I can try drawing a vertical line that will touch quadrants 2, 3, and 4, but not quadrant 1. Remember, it says no points from quadrant 1. So if I draw a vertical line, I could do one here, maybe, or here, or here. I could get quadrants 2 and 3 in there, but if I have a vertical line that touches quadrant 4, it's also going to touch quadrant 1. So there's no way I could get a line that goes through quadrant 4 but doesn't have any points in quadrant 1. So A is going to be a no on this one. Now let's try it with a horizontal one, and I think you'll see something similar happens. If the slope is 0, so I could do a horizontal line that touches quadrants 3 and 4 that has points in each, but if I have any points in quadrant 2, then that horizontal line is going to extend into quadrant 1. So there's no way I could skip quadrant 1 and still have points in quadrants 2, 3, and 4. So we say no to answer choice B. Now for a positive slope, well, if I have anything that's a positive slope, I'll draw a few different options here, but we can see that all of those are going to extend through quadrant 1. And if I have something like here, for example, that touches quadrant 4 at all, even if it's very close to the origin, like the tiniest little sliver in here, if it's in quadrant 4 at all, it's also going to extend into quadrant 1 for lines with positive slope. So we already know that it's going to be answer choice D, and let's just see if we can draw one so that we feel warm and fuzzy about it. Here, the slope of line L is negative. Can I draw a negative sloping line that has points in 2, 3, and 4 without touching 1? And I can. So something like this, anything just below that origin will pass through those other 3 quadrants without having any points here in quadrant 1, and answer choice D is our correct answer to number 8. Now we're going to move ahead and take a look at question 9, and this one has a pretty large table that looks rather complicated, so let's see what they're asking for. It says the table above shows the number of registered voters in 2012 in thousands in 4 geographic regions and 5 age groups. Based on the table, if a registered voter who was 18 to 44 years old is chosen at random, which of the following is closest to the probability that the registered voter was from the Midwest? So here we're only looking at those voters 18 to 44, which means just these 2 columns here. So we can add together those totals to figure out the total voters, 18 to 44. And then for the probability of the desired result, they just want to know, out of those, how many are from the Midwest region. So we're looking among those voters just at these groups here. And luckily, this is the calculator section, so we don't have to do a bunch of messy arithmetic. But to figure out the desired Midwest voters, because probability is always going to be equal to your number of desired results over your number of total possible results. And for this, we're going to have our desired results would be this 34 53 and 11,237. And when we add those, we get 14,690. 14,690. And then for our total, we're adding together these two values here. So it's the 14,766 and the 47,896, which gives us 62,662. And to do the exact math on that, remember this is still just going to be an approximation because they do say closest to in the question. But since we have a calculator, we don't have to worry about trying to approximate mentally. We can do the exact math. That comes out to 0.23 and change, which is close.